Alright, here's IF video number 2. Remember, you have to study everything we've learned. All these videos are not all inclusive of all the concepts you can see. Okay, let's see. Now we're up to completing the square and identifying the vertex. That's going to be in the way. Sorry. Okay, so completing the square and identifying the vertex, the way I've taught you to do this, and this is how you'll see it in most books, you can factor out a 2 out of the A and B. To complete the square, it's split it, square it, add it. So split, square, add. But you cannot complete the square unless you have the A coefficient being 1. So we're going to factor out that 2, x squared plus 12x plus 81 equals 0. Now we have the leading coefficient here is 1. We can split it, square it, add it. So what's 12 divided by 2? That's x plus 6 quantity squared. Now remember, you're adding 36 right here, right? And you need whatever you add to this side of the equation, you have to add to the other. But we're not just adding 36, there's a 2 out here. 2 times that 36 means we're adding 72. Okay? Now remember, we're completing the square concept that I showed you a long time ago. This is x squared plus 12x. When you double distribute, that's that part right there. And then what's hidden in here is plus 36. So plus 36 times 2 is that 72. Got to keep the equation balanced. Okay, last step, subtract 72. So your equation is 2x plus 6 quantity squared. That's a 7. What is that? Plus 9 right there. Okay, so our h lies concept, remember h always lies, so our vertex is going to be negative 6, 9. Let's do the same thing over here. Let's see, factor out the 3, x squared minus 4x plus 53 equals 0. So split it, square it, add it. We got x minus 2 quantity squared. So am I adding just 4? No, I'm actually adding 12. Okay, so add the 12 there. Did I do that right? 3 times 4 is 4, 12. Yep, did it right. So subtract 12, and our equation is 3 times the quantity x minus 2 quantity squared plus 41, I think. And the vertex is going to be 2, 41. Okay, so that's completing the square to identify the vertex. I'm going to move this thing. Give me a second. Alright, let's keep going. On to the next one. Determine algebraically if the function is listed as even, odd, or neither. Now, if you remember the shortcut, we're right here. If you remember the shortcut, use the shortcut. But I'm going to show you determine algebraically because you're going to have to figure this out and show that right there. So here is the first equation. F of x equals 7x to the 4th minus 10x squared plus 18. The second equation is g of x equals negative 7x to the 5th plus 3x cubed minus x minus 5. Okay, so if we want to find out it's even, always start off to find out it's even. The definition of even is if you plug in f of negative x, if you plug in the opposite, then it just spits out just the function. That's what we're going to figure out if it's even, okay? So I'm going to put in negative x's in all these. So 7 negative x to the 4th minus 10 negative x squared plus 18. What happens to this negative 1 to the 4th power? Well, it's because it's an even power, it cancels out. So this can be rewritten and simplified to 7x to the 4th. This can be written as negative 10x squared plus 18. Okay, analyze. What do you have? Is this the same as that? Absolutely. Yep. So f is even. Okay, let's do the same thing over here. Let's see. Start off to see if it's even. Negative 7 negative x to the 5th plus 3 negative x cubed minus negative x minus 5. Okay, so the negative is going to be stay negative. This negative one is going to jump out and make this one positive. So we have 7 x to the 5th. Same thing, this thing negatives because this is odd. This negative is going to jump out. Negative 3x cubed. Negative times a negative is a positive x. And then minus 5. Now, is that the same as this? No. But the next thing, after you see if it's even or not, because it's not even, you got to see if it's odd. Okay, the definition of odd is if you plug in a negative x then the negative just jumps outside, and it's the opposite sign of the function. So can I factor a negative out of all these, and does it become the opposite sign, the same function? So let's see here. If I factor out a negative, negative 1, so it's going to turn that one negative, turn that one positive, turn that one negative, turn that one positive. It almost works. What's the one that screws you over, so it's not odd either, is that sign right there. Okay, so this one is actually neither. All right, that's a pretty long video. I'll stop that one.